This lesson is on the binomial theorem. A binomial is an algebraic expression involving the sum of two unlike terms. An example of a binomial expression would be x plus y. There exists a pattern in the expansion of a binomial theorem. In the expansion of a binomial. You can use Pascal's triangle to observe that pattern that exists. As you can see, whenever you raise a binomial to increasing powers, you form a triangle, and the terms on the sides of the triangles the coefficients are always ones. Terms of the coefficients are ones if the terms in the binomial, if they both have a coefficient of 1. And then the terms on the lines on the lines below, they're always the sum of the two terms above. For example, on the second line, we've got 1 plus 1. The coefficients are 1 and 1. And so you'll see that we get a 2 on the following line in between those two terms. Same thing continues to happen. That same pattern continues. Notice on that fourth line, you've got the 3 as the coefficient. 3 is the sum of 1 and 2 above it. And then the term right after that 3 coefficient, is the sum of the 2 and the 1 above it. And then again, the coefficients continue to be 1s along the sides of the triangle. And again, that's for binomials that have a coefficient of 1. Binomial theorem says that whenever you have a binomial to the nth power, the first term is always going to be the first term in the binomial to the nth power, and then the second term in the expanded binomial is going to be whatever the power is for the binomial, and then the first term of the binomial to the n minus 1 power times the second term in the binomial to the first power. And that pattern continues all the way until you get the last term in the expanded binomial is going to be the second term to the power of the binomial. Let's review what factorial is. Factorial is defined as n factorial is defined as follows for n, an integer greater than 0. N factorial is the product of n times n minus 1 times n minus 2 and so forth, all the way until you get to 1. So what that means is that since n is an integer greater than 0, you never go all the way down to 0. You always stop at 1 whenever you're multiplying the next lowest number. So 0 factorial is always going to be 1. It's not 0. 0 factorial is 1. 1 factorial is 1. Now, to find an individual term in a binomial expansion, you'd use the following summation. You would add up all the terms in the sequence, starting with r equals 0, where r represents the term that you're actually looking for, and n is the power of the binomial. So in this example, we want to find the third term in the expansion of this binomial. So n is 4. R, it's not 3. If you look back at the previous slide, you'll see that we start off with r equals 0. So the third term would actually be r equals 2. The first term is r equals 0. Second term is r equals 1. Then the third term is r equals 2. Plug in everything into that expression. 4 factorial is 24. 2 factorial is 2. 4 minus 2 is 2. And then 2 factorial is still 2. 4 minus 2 is 2. 3 to the second power. And then x to the second power. And then just simplify. 24 divided by 4 is 6. And then 3 squared is 9. 6 times 9 is 54, x squared. So the third term in the expansion of 3 plus x to the fourth is 54x squared. Next, we want to expand this binomial. What we're going to do is follow the pattern that is expressed in the binomial theorem. So our first term is going to be the first term in the binomial to the power of the binomial 4. Next, the coefficient for the second term is going to be the power for the binomial, so 4. And then we take the first term in the binomial, x, and then reduce the exponent by 1, the previous exponent for x by 1, so x cubed. And then the next after x cubed is the second term in the binomial, which is 4. And then the next term in the sequence, the coefficient is going to be whatever n is times n minus 1. So 4 times 3 over 1 times 2. And then x is going to be, it's going to have the first term in the binomial, which is x, is going to be reduced by 1 power. So in the preceding term, it was x cubed. So now it should be x squared. And then the second term in the binomial was 4. In the previous term, it was 4 to the 1 power. So now we write 4 to the second power. And then you'll notice in that Pascal's triangle, it's all the left side of the binomial is always a mirror image of the right side, and there's always one more term in the expanded binomial than than the power for the binomial. So the power for this binomial is 4, so we're going to have 5 terms. So the 2 terms on the right side will be mirror images of the left side. So the coefficient for that fourth term is going to be the same as the coefficient for the second term, 4. And then we continue to reduce the first term of the binomial by 1, so x. Increase the second term of the binomial by 1, 4 cubed. And then the last term is always going to be the second term in the binomial to the power of the binomial, 4th power. And now we just simplify. So we've got 4 times 4 is 16, and then x cubed. 4 times 3 is 12, divided by 2 is 6. 6 times 16 is, well, we haven't done that yet, so 6, and then x squared, and then 4 squared is 16. And then 4 cubed is 64. 4 to the 4th is 256. And just clean up each one of the terms. We get the following expanded binomial. And another, same steps. Start with the power of the binomial, which is 4. So the first term is going to be the first term in the binomial to the power of the binomial, so x to the 4th power. The second term, the coefficient for the second term is going to be the power for the binomial, so 4. And then we reduce the power of x by 1. The first term of the binomial, we reduce that power by 1, so x cubed. And then the second term in the binomial is negative 4y to the fourth. So we want to lastly multiply 4x cubed by that. And then the coefficient for the third term is going to be 4 times 3 over 1 times 2. And that would continue to go up. If there was more than 4 terms, if there was 5 terms, then the coefficient for the next term after this would be 4 times 3 times 2 over 1 times 2 times 3. All right, we continue to reduce the first term of the binomial by 1, increase the second term of the binomial by 1, and then now the coefficient of the second term will match the coefficient of the fifth term. So 4, and then continue to reduce the first term of the binomial by 1, increase the second term by 1, and then the last term, the fifth term in the expanded binomial, will be the second term raised to the power of the binomial. And let's start to simplify. So 4 times negative 4 is negative 16. 4 times 3 over 2 is 6. And the negative 4 squared is 16. Y to the fourth power squared is y to the 8th power. Then we have 4x times negative 4 cubed is negative 64. Y to the fourth cubed is y to the 12th. And then negative 4 to the fourth is 256. Y to the fourth raised to the fourth power is y to the 16th power. And then lastly, clean up everything, and we get the following expanded binomial.